Write the equation of the line given the conditions. Contains the point 6, comma 1 and is perpendicular to 3x minus 2y equals 4.
So quick recall from Algebra 1. I want you to write out slope-intercept form. Slope-intercept form. And it was y equals something x plus b. What was it? mx plus b. And you use this when you have the y-intercept and the slope. Good? And then we have another one. We have something called point slope form. And point slope form is when you have a point and a slope. And that was y minus y1 is equal to what? We did use it last semester. M times x minus x1. And you'll use this when a point is given, and point is denoted by x1 and y1, and your slope is given. Are we good with that? Okay? All right. So then it says contains the point. That's my x comma y. So we already have one piece. The only thing that I need to figure out is it has to be perpendicular to this. So let's kind of recall. When something is perpendicular, my slope was opposite what? Reciprocal. So I need to first go ahead and solve for y on this one. So I'm going to do, are y'all okay if I do one go in this? I know I have to subtract this, and I know I have to divide it by this. Do we all see that? Okay? We're not in algebra, so I'm going to do one go. Y is equal to minus 3x plus 4, all divided by negative 2. So that means my slope in this one is going to be m is equal to negative 3 over negative 2. What is my slope? 3 over 2. And I want it perpendicular. So if I want a perpendicular slope, I need the opposite reciprocal, meaning my sign has to be the opposite, and then flipped top to bottom. Are we good with that? Okay, the pieces that I know my x1 and y1. I know my slope. So I can go ahead and use our point slope formula and plug it in. So here I go. So we have y minus, what's our y1 given? 1 is equal to, which slope am I using if I want the perpendicular?
The perpendicular slope.
Good. Negative 2/3. Very good. X plus or minus? The formula says minus, and then the value given is our positive 6. Everyone good with that? And we do want to solve it all the way. So let's kind of practice with the fraction. Y minus 1. When I distribute, we get negative 2/3 x. Let's think about what would happen right here. I have two negatives. So what operation am I going to have? Plus. So let's see what's happening. In case you're like, I can't do fractions. What is 2 times 6? 12. And what is 12 divided by 3?
4.
Boom. And then my last step is to add 1 on both sides. It sounds very algebra heavy, and it should be. And that is the equation with the condition given. Are we good with that? Okay. Let's go to number 2. For number 2, I'm going to recall what we went over last class. Do y'all remember me saying hoi vox? Hoi vox, okay? So when something is perpendicular, let's write out some little key item. Horizontal line is perpendicular to vertical line. Do we agree on that? Okay? So I gave you what line, if I say x equals 8? That line is what? Vertical. So that means I need y is equal to, what piece is my y between from the order pair? Y is equal to 3. If you're a visual learner, let's go ahead and make our graph. You don't have to, but I'm going to. We have, let's say this right here is 8. We have our vertical line. And let's say here I have my 3. Here I have my horizontal line. Visually, it is perpendicular. If that helps you, write that down. All right, Reagan, let's read number 3, the title, and step 1.
Tangent line exploration. Draw a circle with a radius of 5 and a center at negative 3, 1.
Okay, negative 3, comma 1 is right here. That's my center. And it wants us to draw the radius of 5. So we're going to count to the left, right, top, and bottom 5. So here's 5 here. And then I'm going to count 2, 4, 5 right here. 2, 4, 5 right here. 2, 4, and 5. And then I'm going to mention something that might be thinking ahead. I want you to connect from the center to the y-axis. And then the center, and then from that y-axis to the 5. Should it be up to the 5? Yep. And up to the 5. By that, I'm talking about 40 units above. So if I give you a right triangle, and I give you a leg is 3, and another other leg is 4, that makes automatically the hypotenuse to be what? Isn't that 5 automatically? Okay? I'm pointing that out because at some point I have to write the equation, and we know it's going to go through 5. Just thinking ahead. Okay, let's go ahead and make our circle. I think sketching will be the best bet. It does not have to be perfect. Some of you guys might make a circle that looks more oval, and that's okay. I think mine's pretty good. Okay, William, let's read step 2.
Draw radius to the point 0, 5 on the circle.
Didn't we already do that? So I was already thinking ahead with our prior knowledge. Okay? Peyton, let's read step 3.
Find the slope of that radius.
Okay, find the slope of that radius. Let's go ahead and highlight what that slope is. This radius right here, if I did rise over run, I went up how many and across how many? We went up 4 and across 3. Pierce, let's read step 4.
What would be the slope? What would be slope of the line perpendicular to the radius?
So we wanted perpendicular slope. And again, we said opposite reciprocal, so it's going to be negative what? 3 over 4. Okay, step 5. Vivi, let's read.
Find the equation of the tangent line to the circle at 0, 5 using the perpendicular slope that your equation slope from.
So from this y-axis, I want you to go ahead and use negative 3 over 4. So I'm going to go down 3. So 1, 2, 3 across. 1, 2, 3, 4. And then I think I'm going to go the other way around so I can connect more. I'm going to go across left 1, 2, 3. Oh, right. 1, 2, 3. And then we have 4 right here. 1, 2, 3, 4. And I think I'm going to use my straight edge. If you have your ID badge, that would be wonderful. Let's go ahead and connect through the point of tangency. And these lines, these 3 points should all line up. If it doesn't, you've made a mistake. So what is the angle measurement between the radius and the tangent line always? They're always what degrees? 90 degrees. So here's what I'm going to do. 0, 5. 5 is my y-intercept. That's how I'll write out y-intercept is 5. And we know the slope we're using is negative 3 over 4, so I can use slope-intercept form. So plug in the m, plug in the b, so y is equal to negative 3 over 4x plus 5. Okay, Kilton, let's read step 6.
Draw the tangent line on the diagram and end space with light in the diagram.
So it's basically asking us, how did I make this? Let's verbally say this. Y'all ready? Step 1. I'm only going to verbalize it, so make sure you're writing. Start at the point of tangency of 0, 5. Everyone's writing. Start at the point of tangency at 0, 5. Okay, if you're done, give me a thumbs up so I can give you the second step. Second step, use the perpendicular slope of negative 3 over 4. And step number 3, and then connect your 2 points. We made 3 points just to make it more accurate. Step 3 will be connect your 2 points. Okay, check with your neighbor and see if you have pretty much the same phrasing as what I have verbalized. Oh, it's messy. I'm going to try this one. Okay, if you're ready to move on to the next page, give me a thumbs up. We're good? All right. So on the very top, another reminder, let's write Hoyvox. Horizontal lines have y equals. Vertical lines have x equals. And the key is the y is equal to versus the x equal to. Okay, Esther, let's read the instruction for number 4 through 6, please.
Draw the line tangent to the circles at point A and write the equation of the tangent line.
Very good. So they gave us the point A. So in this case, if I make my tangent line, and let's also emphasize our radius, because the radius and the tangent line are always what to each other, guys? Perpendicular. Very good. So my line that I'm going to write the equation for, is this my horizontal line or vertical line? It is a vertical line. Vertical lines have x equals or y equals? X equals. What number is point A going through on the x? 3. Done. How simple was that? Very. On the next one, Bubba, let's read the instruction for 7 through 8.
For 7 through 8, draw the line tangent to the circles at point A and write the equation of the tangent line.
Now this time my point A is somewhere in the diagonal piece, right? It's not straightforward, unlike 4 through 6.
Yes.
So for this one, let's go ahead and connect our radius. And I want you to do rise over run real quick. Let's apply your Algebra 1 skills. We know it's positive. Okay, my slope, I heard someone say 4 over 3.
Yes.
But because the tangent line is perpendicular to this, I need to make perpendicular slope of what over what? Negative 3 over 4. And then the point is given. This point A, the point of tangency, that point is at 6 comma what? 7. Everyone good with that? Okay? So if you want to do rise over run with negative 3 over 4, go for it right now. But then the grid is kind of not all there, so I think I want to do the equation first. So here's my x1. Here's my y1, and we're using this slope. So it was y minus y1 is equal to slope times the x minus x1. Let's plug them in. Y minus what? 7 is equal to my slope is negative 3 over 4. And x minus the what? 6. Again, it's the fraction multiplying. That's going to be the difficult part. So y minus 7 is equal to negative 3 over 4x. So here's our practice. I need all eyes on the board. Because I have both the negatives, are we okay putting in plus automatically? Okay. So what is 3 times 6?
18.
And then 18 divided by 4. Could we do 18 divided by 4? But let's kind of think about it. If I have 18 on top, 4 on the bottom, can I further simplify that to 9 over what? 2. Let's write 9 over 2. And then we're going to add 7 on both sides. So let's see what's going to happen. Add 7 on both sides. So we want to go ahead and rewrite the 7 as 14 over 2. Because would you agree 14 over 2 is 7? So what I'm adding, 9 plus 14 is how many? How many?
7.
Hopefully you know it was 23. Is it 23 or 21? 23? Yeah, it was 9. So we have negative 3 over 4x plus 23 over 2. So I feel like the most difficult part is when you're distributing the negative and the fraction. What is 9 plus 14? Because I translated 7 to 14 over 2. Do we all see that? So that was our equation. And I'm just going to briefly sketch our tangent line that's going to be perpendicular. In a perfect world, you would do rise over run with negative 3 over 4. If the grid was pretty clear, but I'm good with this. Everyone good with this? Okay, and then one last one before we do number 12. Let's move on to number 10. Okay, on number 10, Aaron, let's read that one. The instruction from 9 to 11.
For number 11, draw the circle and the tangent line through point A if given the radius, the center, and the location of point A. Write the equation of the tangent line.
Okay, number 10 says my center is going to be at 0, 0. Let's all put a dot there. And it's going to go through negative 4. So 1, 2, 3, 4, and up 3. And let's go ahead and connect this. Would you agree if I have a triangle with a side of 4 and side of 3, the radius has to be 5? So that information, to be honest, if it wasn't given, it's not a big deal. Now from here, let's go ahead and count up 5 as well. So we have 2, 4, 5. To the right 5. Bottom 5. It's quite dizzy. And left 5. Okay, let's go ahead and make our circle around those 5 points. And just sketch it to the best you can. Does not have to be perfect. Hey, pretty good. Okay, I'm gonna write the work somewhere. Do I have room somewhere? Let's make it happen. So my point A, that's my point A. So let's call that x1 and y1. Let's first find the slope. My slope of this one is what over what? The radius. It is negative what? How many did I go down and how many did I go across? I went down 3 and across how many? 4. So that means my perpendicular slope that I'm going to use is 4/3. Okay, let's practice our fraction skills. So it was y minus 3. Does everyone see where the 3 is coming from? Okay, is equal to my slope is 4/3. X plus or minus for the negative 4 piece. Plus 4. Everyone good with that? The next piece we have y minus 3 is equal to 4/3 x. Okay, let's go ahead and distribute on this one. 4 times 4 is how many? So I'm going to leave 16 over 3 because 16 cannot be divisible by 3, nor can we reduce any further. And then my last step. I'm going to say plus 9 over 3 on both sides because I know I have to make that a common denominator. Y'all okay why I made that into 9/3? 9/3 is what? Positive 3. It's quite messy here, so I'm going to go down here. So our final equation is y is equal to 4/3 x. 16 plus 9 is how many? So 25 over 3. And yes, your answers are going to look messy, which is fine. Okay? So fraction is our main key on this one. Okay, for number 12. Carson, let's read that one out loud.
Using example A, as point A moves clockwise on the circle, predict where the slope of the tangent line becomes positive. Justify your answer.
Okay, so what would happen clockwise on the circle to the tangent line? So if I go clockwise, 8 comma 3, is that right? Everyone go to 8 comma 3 real quick, put a dot right there. And I wish I have, if I have like a circle that, oh, I do have a circle. I'm gonna model something. A pencil will do. Okay. I have everything. Okay, y'all ready? So right now, imagine A is right here. Imagine 8 comma 3 is right here. Do we all see that? Okay. So would you agree my A is negative slope? And as I get closer and closer to 8 comma 3, what's happening to my line? Tangent line is becoming a what? A vertical line. Do we see that? So I'm going to go one more time. Here's my point A, which I have right here. Here's my 8 comma 3, which I have here. So as I go and go and go and go, it's going to become vertical. Everyone go with that? Okay? Let's go ahead and verbalize that in some form within your group. Give me like 2 sentences of what I just modeled. At some point in the end, you're going to say it's going to eventually become a vertical line, tangent line. But something is happening between A to that 8 comma 3. Give me like 2 sentences. Maybe a long 1 sentence would do. You can say the tangent line as it moves closer to 8 comma 3, blah, blah, blah. If you want to even describe what's happening to the tangent line as we pass 8 comma 3, even better. Okay, be ready to share. And it's okay not to be perfect. Okay, we'll go ahead and read yours.
As the tangent line moves down the circle, the line becomes more and more positive as it gets closer to 8, 3.
As it gets close to 8, 3, it becomes more of a vertical line.
Yeah.
Okay? All right. So I'm going to remodel. Eyes up here. So here's A, here's 8, 3, and here's past 8, 3, right? So my slope is, my tangent line is negative. Would you agree on that? And as we get closer and closer to 8, 3, my tangent line is vertical. And as we pass it, what's happening to my tangent line?
Positive.
It's becoming positive. I need some kind of a phrase in that nature.